Hello friends, this question is from the subject of network theory in the topic of transient steady state RLC circuits. In the problem we have a RC network in which there is a resistor of 5 ohm followed by a voltage source of 10 volt, and there is another resistor attached in the value of 4 ohm. Along with that resistor there is a knob or key which got opened at t is equal to 0. Along with this there is one more resistor, the value of 1 ohm, and there is a capacitor with the capacitance of 5 farad. We need to find out the current across this capacitor or current flowing through the capacitor, ICT, which we need to find out. Okay, so this is the typical problem of transient analysis. In this type of problems we need to observe the circuit before the t is equal to 0, or before this knob or switch will be closed, because at t is equal to 0 the switch will be open, which will make a sudden change in the circuit. Before that, at t is equal to 0 minus, when this knob is closed, the circuit is in a steady state. So we need to observe the circuit before or at t is equal to 0 minus, and then we will proceed to the t is equal to 0 plus, or when the knob is open. So let us draw the equivalent circuit at t is equal to 0 minus. So at t is equal to 0 minus, we have the same voltage source, 10 volt. The resistance 5 ohm. This resistor is 4 ohm, and right now knob is not open. Right now knob is not open. So there is a short wire, and there is one more resistor 1 ohm. But we know that in a steady state the capacitor behave as an open circuit for the DC input. This 10 volt is a DC input. So before the knob will open, or at t is equal to 0 minus, my circuit is in a steady state. So my capacitor will behave like an open circuit. So this terminal is remain open. So voltage across these two terminals is VC, or voltage across point A and B is VC. But there is a close. I can observe the closed loop here. So I will find out the current I in the current I of this loop. So the current I of this loop will be the effective voltage of this loop, which is a 10 volt, and the effective resistance is 5 plus 4 is 9. So the current is 10 by 9 ampere. It's flowing in this loop. So when the current is flowing, the current flow. So and the current flowing across the resistor 4 ohm resistor is also I, because 4 ohm is in the same loop. So if I may find the voltage across the capacitor C or VC voltage, so it will be the voltage drop across the resistance 4 ohm, because there is no drop across the resistance 1 ohm, because 1 ohm is attached with the open circuit, so there is no current flow. When the I is 0 of this resistor, so there is no voltage drop across this resistor, so the entire voltage drop or entire voltage across the 4 ohm will be transferred to the capacitor. So VC is will be simply the voltage across 4 ohm, which is equal to the minus times 10 by 9 into 4. Why this minus? It's minus because my current is flowing from B to A. From I current is flowing from ground to up. Or if I make all this term as a B and is a A dash, so my I is flowing from B dash B to A dash. On the other hand, I am observing my VC from A to B, from A to B VC. So there is the opposite of direction, because current always flows from positive to negative. So voltage VC, so current across the capacitor IC should flow from plus to minus, from A to B. So there is the direction is opposite for current IC and current I. They both are in the opposite direction. The I is flowing from B to A dash, and VC, if it may flow, so I'm observing VC from A to B. So there would be a minus sign, because this terminal is actually negative, but I'm considering this terminal as a positive. You see. So I need to put a minus sign here. So it is clear that my VC voltage VC is negative. So positive. It is 10 by 9. 10 by 9 is my current, and 4 is a resistor. So my VC is minus 10 by 9 into 4, or minus 40 by 9 volt. This is the VC 0 minus, because this is the voltage of capacitor before the switch is open. Voltage of the capacitor at t is equal to 0 minus. So now if I may draw the circuit after the switch is closed, t is open, sorry, switch is open. Or I mean the steady state circuit. Steady state circuit. So I have opened the circuit and I am observing it after a long time. Okay, I have opened the circuit for a long time at t is equal to 0. I have opened it and now I am observing it after a long time. So while my switch is open, so this terminal will be open and my 1 ohm is resistor, but this capacitor is still open, because I have observing the final value of capacitor VC final, because I have opened the switch and I have left the circuit for a long time. So it is VC final, the final steady state value of capacitor. So this capacitor is again saturated and behave like a open circuit, because the circuit is remained open for a long time. So there is no closed path in this circuit, so there will be no current flow. There will be no current flow. The entire voltage 10 volt will be transferred to the VC. And we can see that the negative terminal of 10 volt is attached to the positive terminal of VC. So my VCF or VC final will be minus 10 volt. With the positive terminal is correspond to the negative terminal of the voltage source. So VC final will be minus 10 volt. Okay, so let's find out the RTH or equivalent resistance of the circuit. Find out RTH. For RTH, for Thevenin equivalent resistance, we will short circuit the voltage source. So our circuit will be 5 ohm, this 4 ohm, so there is open circuit, and this is 1 ohm. So we are finding out the resistance RTH across the terminal A and B. So my RTH will be series combination of this 1 ohm and this 5 ohm resistor. So it will be 1 plus 5 is equal to 6 ohm. So I know that my time constant is RTH times C, which is 6 cross 5 equal to the 30 seconds. So time constant of the circuit is 30 seconds. From the network analysis or from the charging or discharging of the capacitor, we know that the expression of capacitor VCT is equal to the VF final value of final voltage of across the capacitor plus VC0 minus VF into e raised to power minus t by tau. So from the circuit we know that the final value of my capacitor is minus 10 volt, and from the earlier we have calculated the VC0 minus, which is equal to the minus 40 by 9. So if I may put these two values in my circuit, in my equation, so my VF will be minus 10 plus VC0 will be minus 40 by 9. Here minus of minus 10, it will be effectively plus 10 e raised to power minus t by 30. So this circuit is simplified as minus 10 plus 50 by 9 e raised to power minus t by 30. This is the voltage across the capacitor. But we need to find out the current across the capacitor, which is ICT. So from the capacitor equation, we know that the current across the capacitor is related to its voltage as ICT as C dVCT by dt. The current across the capacitor, which is nothing but the differentiation of the voltage across the capacitor. We already know the dVCT, we know the value of capacitor C, we know VC expression of VCT, so we can easily evaluate the ICT. Let's put the values here. C as 5 d by dt. The expression of VCT is minus 10 plus 50 by 9 times e raised to minus t by 30. Let's differentiate this equation. We know that the differentiation of the constant is 0. It is 0. 50 by 9 e raised to minus t by 30. It is minus 1 by 30 times e raised to power t by 30. If we know that the d by dt, we know that the d by dt of e raised to minus a is minus a times e raised to a. So that the same property has been applied here. So my expression will be 5 times minus 50 by 270 e raised to power t by 30. If I may further simplify this expression, so it will be ICT is equal to minus 25 by 27 e raised to minus t by 30. The current flowing across my capacitor C with the magnitude of 5 farad capacitance. So my correct option is D. Transient analysis is a very important topic in the network theory. Every time you can expect one or two questions from this. This topic is also very important in terms of common data. Thank you.